Hey everyone, now that we have this idea of using antiderivatives to find the value of definite integrals, I want to sneak in another kind of nice use of integrals. So I want to talk about average value, and just as kind of a warm-up question, I want you to think about how you would calculate an exam average. So I'm hoping that what we're thinking of is if we wanted to calculate an exam average, we would sum the scores. So we would add up all the scores, and we would divide by the number of scores. Okay, so with that in mind, I want to talk about how you would calculate the average value of a continuous function. And when I say value, I mean I want you to be thinking y value. So let's say I have a picture. What's my calc2 function? This guy, whatever it looks like. And this is my y equals f of x. And this is my x, and this is my y. And I want to say from A to B, what is the average y value? So I know that typically what I would want to do is take all of the possible y values, add them up, divide by the number of y values. But that gets a little bit complicated when you have a continuous function and there are infinitely many y values. So we're going to go back to what's going to be a real theme for this class. When you have a situation that's a little too complicated because you have infinitely many of something, or you're trying to, if we're thinking Calc 1 problems, you're trying to estimate something about steepness, but you have a curve, anything like this, we're going to work on little tiny small pieces and see if we can get the right idea. So for this one, let's just say that instead of trying to add up infinitely many y values and divide by infinity, we're going to estimate that by splitting this into n subintervals. And we're going to take a y value on each subinterval. So we could pick an x value within each subinterval and plug it in. And you could use left x values or right x values or whatever. It doesn't really matter. But let's just say we're going to pick an x value on each one of these. So we'll say that the first one is x sub 1, and we're going to plug it into our function to get a y value. And then we're going to take our x sub 2, which would be any old x value in the second one, and plug it into our function. And we're going to keep doing this until we've got one for every subinterval, which means we'd stop at x sub n. And if we want to get the average, we would then need to divide by n. And I want to think a little carefully about this. If we have n subintervals, then we actually know something about n. We know that, well, here, we know a couple ways to say this. We know something about delta x is b minus a over n, which means we can rearrange a little bit and say, well, then n has to be the same as b minus a over delta x. So just multiply both sides of your equation by n, divide both sides by delta x. So here we'll just say this. The average, we'll use the notation we're going to use, f average, that's supposed to be an AVG, is approximately equal to this, which we can then say is the same as f of x1 plus f of x2 plus all the way up to f of xn. And in fact, I can do even a little, I'll save it for one more step. We can use our sub notation over b minus a divided by delta x, which means we can actually flip and multiply and say we're going to have this multiplied by delta x over b minus a. So we now have that the average value is the same as f of x1 times delta x plus f of x2 times delta x plus all the way up to f of xn times delta x. And that is divided by a b minus a. Okay, getting close. So now I'm going to switch to my sigma notation. I'm going to say here, f average is approximately equal to the sum of the f of xi's multiplied by delta x's, starting at I equals 1, stopping at I equals n, and then we want to divide that by the length of the interval, b minus a. So now, if we want the exact value instead of the average, so now we're going to actually claim equals, all we have to do is let the number of subintervals go to infinity. So we're going to take the limit as n approaches infinity of the sum of the f of xi's times delta x's divided by b minus a. Oh, and let's see if I can sneak this in. I needs to start at 1 and stop at n.